Hey guys, StatsGuru here, and in this video I want to touch on z-scores, kind of what they are, and walk through two examples of how to calculate them for a sample. So if we think about z-scores, I have a little definition here. It really measures how many standard deviations, whether it's a population or a sample, and how far away we are from the mean. So we can either be above the mean or we could be below the mean. So again, a z-score is calculating how many standard deviations away we are from the mean. And when we think about the standard deviations and z-scores, we do have, of course, two formulas, one for a population and one for a sample. So our population z-score formula, we're simply going to take our observed value and we're going to subtract the mean. And then again, we divide by the standard deviation. So this would be for a population since we're dealing with mu and the population standard deviation here. If we're going to have a sample, it's the exact same thing. So we're just going to have our observed, and of course, we're going to minus the sample mean, which is x bar, and then we're going to divide by that standard deviation. So when doing z-scores, again, we have two formulas, the population or the sample. Essentially the exact same thing, just depends on what the question is, if you're working with a population or if you're working with a sample. So let's jump right into a quick example of calculating z-scores. In this first example, we have final test grades of students in a given class, and the teacher is going to fail anyone who is farther away than one standard deviation from the mean. So we're asked to find the z-scores of these students and figure out who is actually going to fail the class. So we have all of our scores here. We have 10 individual students. We were given an average of 58, so that's the average test score on the final exam, and we have a variance of 162.22. So now we're going to find the z-score for each student and figure out who is further than one standard deviation away. So here are all of the z-scores calculated for each student. So we went ahead and used again the z formula. So just to reiterate, that's going to be our observed value, and we're going to subtract the population mean, and we're going to divide by the standard deviation. So as we went through and calculated for each of these, we are looking for those who are greater than one standard deviation away from the mean. And in this case, since we're dealing with test scores, we would want somebody that's below the average. So as an example, we do see this 81, and they're actually 1.8 standard deviations above the mean, but you wouldn't fail somebody that's above the average. So we're going to search for people who are one standard deviation or more below. And as we go across here, we see that this student is negative 1.23, and we see that this student is negative 1.33. So we have two students here that we can identify as failed for the class on the final exam. One thing that's kind of interesting is the average was 58. So if you scored a 50, if you scored a 51 or a 55, you may be thinking to yourself, geez, we totally failed that. But one thing to consider is this teacher is going off the class average, which can be helpful for some students, because at that point he's going to look at everyone's score and how many standard deviations away they are, and from there calculate the grades. So in this case, only two students actually failed the class. So I hope that's a good first example. Let's look at another example. So we are looking at M&Ms, and a regular pack of M&Ms has an average of 19 pieces with a standard deviation of 1.2 pieces. So out of curiosity, you ended up buying 10 packs to actually test this theory. So let's go ahead and find the z-score for each pack. So before we do that, what do we need? We need to calculate the average. So our average is equal to 19, and our standard deviation was given to us, which is 1.2. So now we have everything we need to use the z formula. So again, it's going to be z equals our observed minus our average, and we're going to divide by standard deviation. Let's go ahead and calculate the z-score for all 10 of these packs. Now, after calculating the z-scores for these 10 packs, we see that we do have a couple zeros. In that case, what we had was we had 19 minus 19, and we divide by our standard deviation, but of course 0 divided by anything is equal to 0. So that's where you get a z-score of 0, meaning it's right on average. In looking at this, we can see that we have a 1.67 here, we have a negative 1.67, some 0.83s, and then over here we actually have a 2.5, so this one's 2.5 standard deviations above the average. In this case, we weren't asked to do anything more other than just calculating the z-scores, so this would be the z-scores for each individual pack of M&Ms. So those are just a couple examples walking through how to find z-scores and the formula. I hope that the z-score formula is easy to follow along with, and I hope that these examples are helpful for you guys. As always, comment down below any other topics that you would like some examples for. I'd be happy to make a video for you. And make sure to hit the like and subscribe button, and we'll see you in the next video.